drop me an email. We'll find person, Skype, all signals, whatever works for you. Okay. So let's go into. We'll continue. As I said, the very last thing that we went through was the Postpartum, which is that period of uterine evolution, reestablishment of the ovarian cycles. We said in the previous class, perhaps one of the most important points was the fact that, the suckling effect of the offspring into blocking GnRH and LH, release, which keeps the animal from an ovarian point of view, what we call in an anovulatory condition. You still have the phases, the growth of the follicles, but no actual ovulation. On the uterine side, we mentioned that all that catabolic activity that has to go on, inside the uterus to remove, after the removal of the fetus and the remaining of the placenta and other extraembryonic membranes, you still have a place that is very suitable for bacterial growth. So you have to remove that basically in two ways. One is by having your immune system super ready, to fight that infection at the same time that you need the mechanicals of the uterine. When I say mechanicals, the contractility of the uterus to provoke the expulsion of whatever material that is inside. And all of that to complicate even more is having that idea that, the animal at that point, it is a physical strain. Immunologically, the animal is depressed because during the process of parturition, you have lots of cortisol hanging around in the circulation. And to be even more challenging, you have then the production or the initiation of the production of milk, which from a metabolic point of view then becomes a big deal. All of a sudden, you are producing relatively large amounts. And when we're talking about domestic animals, even if you remove dairy animals aside, the animals have been selected to produce quite a bit of milk. If not for human consumption, it is for the greater or to take care even better of the offspring, which basically will be returning from the economic point of view to animals with better weight gain and so on. So all of that brings this enormous challenge for that period of time. As mentioned before also, that most of the domestic species, 95% of the problems will occur around this time. Okay, lots of too many challenges at the same time. Now, when we went to explain a little bit of the milk production side, the development of the mammary gland, we started by saying that the mammary gland, you have an initial stage of development, which we call normally mammogenesis, which is that it's basically the formation. We could say the embryonic, but it's not embryonic, but the initial formation of the mammary gland, which goes along with the actual formation of the female reproductive system, even in the fetal stages, embryonic and fetal stages. The early development, as you would suspect, it does not depend on hormones. It is just after you have XX or XY chromosome, your reproductive system will divert early in your embryonic life. And then after that, you're going to be set up with the external female or male reproductive system. Now, as you move into the development, like the prepubertal and pubertal stages, you're going to have a further development of that mammary gland, which again is not a full development. It's just the early stages of the formation of the mammary gland tissue, also with quite a bit of adipose tissue that goes along into that gland. I mentioned that also that the idea of having the mammary gland with lots of vascularization, lots of adipose tissue, as well as lots of parenchyma, which basically is lots of the actual mammary gland tissue, is that all of that will be needed in order to produce these vast amounts of milk. If you think about a gland, no gland will produce as much material as the mammary gland does from an energetic volume standpoint. It really is a unique gland in that sense. Then after that initial stage, we go into another stage before this one, what we call lactogenesis, which basically is, and lactogenesis starts right before parturition, which is what? Is the beginning of the actual production of milk. And by then, you actually have to turn a very inactive gland after that point to a very active gland. Okay, so cells, I think one of the slides before was that polarization of the cell. You have changes in the cell component. You have changes in the number of cells in that alveoli of the gland, you know, that is producing milk. You're going to have lots of enzymatic activities going on, you know, in those cells. Those cells, among other things, they will produce. If you think about milk, and in some ways, is not only they are filled with energy and protein and fat, which basically means they have to produce some, they have to repackage some. When I say repackage, part of what you eat, just is, you know, repackaged inside of your organism, is inside also of the alveoli cell, and it goes into milk. But also the cells inside of the mammary gland actually produce certain kinds of fat. Okay. I mentioned also, like, in terms of the hormones, it divides a little bit into the steroid hormones that, you know, are necessary for the development of the ductile system, so ducts and tubules, you know, inside of the mammary gland. And then you have another set of hormones that are necessary for the diversion of energy from the body or what you eat towards the mammary gland, and obviously another set of hormones that then are necessary to make those cells very active. Rule of thumb, say whatever hormone probably is there, but think more of the actions of that whole hormone. It's much more important for you to understand that you have those three blocks of hormones that, you know, you will depend on, you know, the mammary gland will depend on to live to the full potential, okay? Galactopoiesis is just this other weird name that then it has more to do with the maintenance, and also, which the maintenance is pretty similar to the actual lactogenesis and stuff, but then to the persistence of lactation. And when I say persistence, is that during the production cycle of milk after parturition, you're going to start at a certain amount, depending on the species, you're going to reach a peak, and you're going to decrease. Some species decrease really fast. Some species have a long persistence of that production. Most of that is dependent on how you keep those cells alive, the cells of the alveoli alive. Naturally, they will go into what we call this programmed cell death, apoptosis, and eventually you're going to have that mammary gland that from a macroscopic view goes from relatively small to quite big and then shrinks. That shrinkage is not because you're using adipose tissue or other things or vascularization decreased. It's because the number of cells in the mammary gland are also decreasing. So you have to have some of that. Lots of things affect the way, you know, that shrinkage occur. It goes from species to breed to feeding to stress to how you remove the milk. All of that in some ways affect. If you don't remove the milk, you're probably going to stop producing milk faster. So the only stimulus of removing the milk actually makes production even more, to the animal to produce more milk. We talked about some of these things in terms of what is needed, mobilization of energy. This is not so different than the previous 2 or 3 slides. Now, the next slide is going to talk a bit about, okay, I think this is where we really stopped. We're talking about calcium, which is perhaps, aside from energy, I know fat and protein are super important. We mentioned, I think in the previous class, we talked about maybe 5-10 minutes about how the body tried to divert a little bit of the energy towards, the mammary gland. It has to do with insulin, how some tissues do not depend on insulin. But the other thing that it tends to be super important is indeed calcium, because milk has quite a bit of it. It has to come from somewhere. And imagine if you're producing 10 liters of milk, 20 liters of milk, 30 liters of milk, 40, 50, it has to come from the diet, and it has to come from your bones. Okay? The body will have to have a system in which it has to basically scavenge calcium very quickly from your bones to then go into the milk. That's why in species like those very high producing animals, cows, they tend to have problems with hypocalcemia. Not that they tend to have, it's common in certain stages, especially really after parturition. And it's not because the animal is not able to do it on, like, for example, during the lactation, but it's just in that transition from non-lactating to lactating, you end up having a switch. You have to really go from not producing or producing zero milk to producing 30 kilograms of milk or 30 liters of milk all at once. That amount of calcium that has to get out of your bones is too much. So sometimes it's common for cows to enter this hypocalcemic state, which today you have ways and ways to prevent. It's not, really well managed farms, they don't go into much into that problem, but it is just something of concern, okay? For that, parathyroid hormone, vitamin D, these are things, calcitonin, those are the hormones that actually, do something in terms of either vitamin or calcium absorption or resorption from the bones or reinstatement of that calcium into the bones. Then a few things on milk removal. All the time when you remove milk, you release prolactin, you also release oxytocin. Eventually the pressure inside of the mammary gland decreases, and this effect of decreasing the amount of milk inside actually prompts the mammary gland to actually start producing more milk just because of this pressure, that filling effect that you have inside, the mammary gland. So this little part here, it is very simple. The ejection of milk, in one of the previous slides I showed that, inside of each of the alveoli, you have lots of vessels, you have adipose tissue, and you have tiny muscle cells that we call myoepithelial cells around each of the alveoli. This is very common in each and every gland you have in your body, but it tends to react really well to oxytocin. Okay, oxytocin is really well known for having this contractility effect. There's a series of drugs that end up having, and is always associated with, the contraction of muscles. And as you have this, or you have nerve receptors, this one, or the nerve receptors with the suckling effect, that stimulation goes into the afferent or efferent nerves, going to the spinal cord, going to the hypothalamus, going to some of those supraoptic or paraventricular nuclei. I don't need to really know or memorize those, but it has to go into the hypothalamus and release oxytocin from the posterior pituitary. As is released from the posterior pituitary, it goes into the circulation, go back to the mammary gland, reaches the receptors into the myoepithelial cells, and the myoepithelial cells squeeze the alveoli. Okay? Can you use oxytocin, exogenous oxytocin to stimulate a little bit milk let down, you can. It's not ideal, but you can if needed. Like this ejection, although, from a physiological point of view, is relatively simple, it is something of great economic interest. You may not realize or may not give so much credit for, but the idea that you have to have a certain routine of animals in order to, remove milk from those animals, it really tends to take not only a calm environment, but normally animals, when you picture a dairy farm being cow or goats or sheep or whatever animal that you're taking milk from, the idea that you have from those farms is that is a very calm environment. Those are not very aggressive animals. They cannot be, because you're going to deal with those animals 2, 3, 4 times a day. So they tend to be really on the calm side, and they have to be that way, otherwise they're not going to give so much milk. So stressful situations that can release epinephrine, norepinephrine, cortisol, all of that tend to have a blocking effect on how milk let down is done. So it is a simple, but tends to be very important process there. As part also of this galactopoiesis is the mammary gland involution. So this involution, which I said previously, is this shrinkage of the mammary gland. It has a lot to do with the loss of tissue, in this case, the degeneration or loss of mammary epithelial cells. This is the major part of how those cells, or that mammary gland as a whole, decreases in size. When I say here decreasing lactose, obviously there is an overall decreasing cell number, which leads to a decrease in the volume of milk that you produce. But at the same time, you have lactose, and lactose is basically the sugar, of milk. This is what gives you in some people, intolerance, because it's not, it's a very specific disaccharide, and sometimes some people, either from the get-go or through their lives, may start losing that enzyme, lactase, and that's what triggers lactose intolerance in some people. So you cannot break that down, so you cannot absorb. You keep it in the lumen of the intestine, it draws water. Normally, people with lactose intolerance, they will end up having quite a bit of diarrhea because of that. So this is what drives also a little bit of the reduced, milk production. Lactose, during the formation of milk, lactose is what, because of osmotic pressure, it draws a lot of water to the globule that is produced. So when you have that saccharide, if you have more lactose, normally you tend to have is what really drives the accumulation of water into some of those globules, and that gives more volume to the milk. So this lactation, or this rapid loss of tissue function, this is what I mentioned in the previous class also, onto how some of those drugs to increase milk production, such as growth hormone, so BST or recombinant bovine somatotropin, depends on how it is marketed in some places. This is what people have used, with a certain frequency in animals to keep production high. Why? Because the growth hormone stimulates lots of some other hormones, such as insulin growth factor 1. And these hormones are known for keeping tissue function alive for a little longer. Okay, so those are hormones that are really tied with the metabolic state of the animal. And if you have a little bit of those hormones, it means that the body understands as if you are in a good metabolic state, basically speaking. So you keep producing quite a bit more. That in turn makes you either eat more to produce more, or you start burning or you start mobilizing internal fat stores. Okay. So over here is just like in all the production systems, once you went or you go into the final days of lactation, and think about this. In one thing that sometimes we don't really think about that is that most of the animals and domestic animals that we need them to reproduce quite often, swine, dairy and beef cattle, sheep, so all of those, the usual suspects, you want them to reproduce with a certain frequency. And we tend to push that reproduction to occur with a frequency that is very tight, let's put it this way. That means that most of the animals in a certain environment, in a farm, they will be, for example, or they could be lactating and pregnant at the same time for a big part of their lives. Okay, so dairy cows is a typical example. Some of the other animals, a little less so, especially because they either have a lactation period that is too short, or they just have a period where the intercalving interval or the interparturition interval is too long. So they first lactate and then they return cycle. But dairy cows, typically, or dairy animals, they typically be or are in pregnant and lactating at the same time. One thing that they have to actually do is to, before or pretty close to the next parturition, they have to stop milk production. And the idea there is that, first of all, you have to give it a break to the animal from a tissue point of view. So the mammary gland has to finalize complete involution to then prepare for the next lactation. But Ronaldo, would it be possible for you to get pregnant, lactate, and then have a parturition and continue lactation? You can. Several animals, you can do that. The only thing is that probably your mammary gland will not be as productive in the second one as it was in the first one if you don't give it a break. So you do need that tissue to completely involute, and then going to the same process of lactogenesis again and galactopoiesis to then regrow and start producing milk all over again. And then we are then going to probably the other more important, or another portion of the class that is quite important, which is then, so we completed more or less the whole production system. So all the way from initial development of the mammary gland to then lactogenesis, galactopoiesis, and mammary gland involution. At the very, very beginning of the lactation, few days after parturition or a couple days after parturition, I mentioned before that the animal will produce a milk that is slightly different than the actual milk that we see, for example, in the shelves of supermarkets. Okay, so we mentioned that that milk is really white in color and so on, but the initial milk, or the milk of the first 2 days, is what we call colostrum. Okay? This colostrum is then important for a few things. So this is the first product to be synthesized. They have way more solids than the actual milk that the animal will end up producing for the rest of the lactation. In general, you can say as a rule of thumb, you're going to have twice more solids. And when I say twice more solids, overall speaking, if you put everything, protein, fat, carbohydrate, and minerals together, and you have on a dairy cow's milk, 15% of solids, you're going to have 25-30% in the colostrum. So it's a much thicker liquid, is much richer from a nutritious point of view. But you will also see that this guy here, IgGs, or immunoglobulin Gs will be quite important for what we call later as passive immune transfer. So in not all species are super dependent on that. This has a little bit to do with the type of placentation. I think, eventually we mentioned that, if you can pass those IgGs through the placental barrier, then probably during gestation, you're going to receive some of that. But if your placenta do have too many barriers, and when I say too many barriers, that typical epithelial chorial placenta, where you have like not much contact at all and lots of barriers between the two blood pools of the mother and the baby, then you have more difficulty to pass large and very large molecules, in this case, very large protein molecules. This thing that is called transition milk is basically from going to colostrum to the regular milk. You have a couple of days there where that total solids that I studied was on the 25%, 30% in many of the milk that we're used to. It goes to a little less until it reaches the actual milk that we are accustomed to. Does it mean that we don't have much of this milk or the transition milk to that goes into the actual tank that then go for human consumption? In general, especially the first 2-3 days, it doesn't. Normally you milk those animals, and if the animals, like their offsprings, cannot consume it all, what they end up doing is you end up freezing some of that and giving to other animals too, as possible. Or you give part of that to other calves, because you have to give a portion of the milk you produce to the calves that are being grown in your farm. So that's normally how they do it. This is just more or less what you find in terms of components in milk of different species. They tend to be, I shouldn't say similar, but it is in terms of total amount of solids, they tend not to be all that different. If you go into the wild and say, oh, what about the milk from whales or the milk from very different, you're going to have a lot more than that, okay, in terms of solids. So it's a very fatty kind of milk. But some of these numbers here, for those of you that work in animal science, and then you have to eventually, if you end up working in these areas, these are numbers that you get very used to, because you actually get, in Canada, for example, you do get paid by the amount of fat that you have in your milk. So can you modify the amount of fat that you produce in milk? You can modify it quite a bit, depending on what you eat and how the feed is offered to the animals. You can modify fat quite a bit in milk. Much more difficult to modify protein, even more difficult to modify lactose, but fat you can modify quite a bit. So at the end of the day, in Canada, for example, you tend to be less concerned about total volume and more concerned about total solids, or total amount of fat that is in the milk. So that led, for example, to more emphasis into the genetic selection of animals that produce a little more fat, or you start going into breeds that have a little more fat. So in the case of dairy animals, you have heard about the name of this breed that's called Jersey, which is like a brown, relatively small cow. They produce a lot of fat. They don't produce as much milk as the big, white, black and white cows, Holstein cows, but they produce a lot of fat. So in certain places, they even prefer to have an animal like that. It's a little smaller, but produce a little bit more of solids. If you compare then, what would be, and this is for a typical dairy cow. This is the first one, which you would tend to call this the actual colostrum, all the way to what you would call the regular milk. You see that it goes from this. It goes from about 24, 25, all the way to 12, 13. So you basically have twice as much stuff in that first milk. The other part here, if you think about this, is that at this point here, you have almost zero of those. By the time you have the fourth milk, you have very, very little IgG. But then you see here that in the beginning, especially the first two milkings, you have quite a bit of those immunoglobulins. There's two things there then that are important for you to understand in terms of this idea of passive, immune transfer. One is that it only works, of course, in the first milking, especially. First, maybe the second milking, to have enough, the amount of IgG that is enough to have an impact on the offspring. The other one is the timing in which you give that feeding or that colostrum to the offspring. It's not like you can, let's say, oh, my immune system is not too well, so I'm going to drink a glass of colostrum, so that will be good. No, it's not going to be good, first because you cannot absorb that. And that's the whole problem. Those are, as I said, very, very large molecules that is, in theory, they have to be absorbed intact as a whole. And remember the classic picture of an immunoglobulin? It looks like a Y. It has like two little antennas and a little body. That thing is relatively large from a molecular point of view. So you have to have that thing being absorbed as a whole. The problem is your intestines are not, adult intestines are not like that. And when I say adult, by the time you're the second day or third day of age, your intestines are relatively closed. But in the first few 6, 12, 24 hours, the intestines of younger animals, especially those that depend a lot on IgG consumption to have some sort of immunity to get going, those cells are relatively spaced. So you have quite a bit of space. And when I say space, the cells let go in between them lots of large molecules. And that's what prompts the colostrum to be absorbed in vast amounts and the IgG to actually go into the bloodstream of the calf or the younger animal intact. Okay? And by the time these immunoglobulins enter your system intact, then it's you can ask, how important that is. What difference does it make for an animal to consume those vast amounts of immunoglobulins compared to those that didn't? It goes from having a 2 to 5% mortality rate to 40% mortality rate. That's how important that is for that initial boost of immunity, from these animals. These animals then, they have to rely, if they don't have that, there's very little their own immunity can do. They're not yet ready to have their immune system completely mature to fight, especially more intensive infections. So in the beginning, if you don't have that, an animal, as you probably can relate, especially for human babies, what really kills in the beginning is not necessarily a very complicated disease or anything. What normally kills offspring is dehydration, is diarrhea, is pulmonary flu, something like that. It's very simple stuff. So at the end, if you don't have that initial protection from immunoglobulins, you end up in big trouble, even if you are in a clean environment and so on. So this is basically what it is. Different people do it in different ways, but for the most part, you have to give that colostrum really early on. This is one of the reasons why in certain places you have that tube feeding. So you basically, because sometimes the offspring is quite weak, so it doesn't necessarily stand up to start suckling, that colostrum naturally from the mother. So normally, or not normally, very often, what happens is that humans will go there, milk the colostrum, and actually force feed, the offspring to drink that colostrum. Is it ideal? Probably not. It is worth, I think it is, just because it's a very, very important window, in their lives. And then is the last one. Yep, directly to mother, management, density and total protein. Sometimes you have different types of measurements there that you can do with the colostrum in order to measure quality of that colostrum. Does that mean that, you can sometimes, I don't know, vaccinate the mother to promote the production of certain immunoglobulins in the mother that then goes into the milk and then you give it to the calf? Sometimes that's the route you take. Certain vaccinations can be done before calving, for example, in order to promote immunity indirectly to the calf.
Can you also just directly give immunoglobulins to the calf? Like vaccine-wise?
You can, but the thing is you have to wait. The first set of vaccinations for certain animals, you're going to probably have to wait 3-4 months. Otherwise, the animal will not, as I said, the immune system is not ready enough to start producing immunoglobulins on their own. But yes, eventually you're going to do that. But the thing is, you're trying to provide protection for the first month or so. I think that's the only thing. That thing eventually you're going to start producing your own, so you're able to measure a little bit better. Very good. So I think that's nice. So I think that's pretty much it for the mammary gland side of it, and I think we covered pretty much the whole thing. Right now, then, what we can have is, normally we have, let's have a break, but it's a big break now. So what we can have is, I'm going to stay here, and whatever you may want to ask from, I know some of you already have, presentations, Janet will be here as well. What do you expect from evaluations of this? I decided, for the quizzes, your worst grade we can remove, from the quiz. So those of you that were too concerned about what did I do in my first quiz? No, that's okay. We can remove, and maybe the second one you slept over and you didn't come. That's fine. So this is one. So we're going to remove that. In general, the final, as I said before, is very similar to the questions, the type of questions that I asked in the quiz. In the presentations, I think the groups are from, how many in the group? 4 or 5?
4 to 6.
4 to 6.
Yes, we have one group of 4, a couple groups of 5.
Okay. So somebody asked me before also, is that a group grading? Is that individual grading? I normally do individual. I go into each review, and some parts of the presentations, maybe some of you are not familiar. I expect you to ask questions, but if you don't, I will. It's going to be awesome. Like we keep like another 15 minutes asking questions, and it is not. Normally it's, don't panic. It's all good, but it's just a way for to test a little bit how much you actually went to it. Part of the, each and every of these technologies will be related to the classes that we had. So if you're going to talk about sex semen, and how sex semen is done, yes, probably I'm going to ask you about capacitation, about acrosome reaction, about morphology, about stuff. So the idea is that I have you studying already a little bit for that. The second part is don't let, because you're going to present one and hear another 10. So the idea for the presentations is that you come here and you try to teach the rest of the class about a certain technology. That means that you come here and not vomit stuff That means that you don't come here and say, oh, this is the fancy stuff. No, no, it's supposed to be, you can be as broad or as specific as you can. It's your decision. If you know, sometimes those are the questions that come up. Oh, if I'm going to talk about embryo transfer, how would you like me to do? I think you have to think, the idea is that you come up with, you know, if I were to receive this class, what would I do? If I were to explain to you what is a synchronization protocol, you know, for ovulation, how would I like, you know, this other person to teach me about that? So the challenge is also to give you a little bit of independence for you to come up with your own way of doing that. With that said, then I think it comes the other challenge of whatever you put, and I understand today, you know, it's relatively okay for you to go and say, oh, let's have this presentation. I think if you look hard in Google, you're going to even find a ready, you know, somewhere on the planet. There must be an embryo transfer presentation ready somewhere. The thing is, I tend to be picky about what you write on the slide. If it is just to fill up space, don't do that, because it just gives me material to ask you. Okay? So that's So if you have something on the slides, make sure, because at the end of the day, given the time, the amount of the time that you're going to have to present, each of you will present what? 2, 3 slides, maybe 3, 4, depending on how you, if it is like, I think it's okay for me to ask you to really know those slides. Okay? Get to know those things, and not only those slides, but I get to know the presentation. This is supposed to be part of my philosophy is that, and that goes with the labs, and that goes with the presentations. Traditionally, the presentations, I tend to be hard on the questions when I ask, very easy on the grading. But the idea is that you come here to learn. I understand grades are important. I hate grades. You know, that's the very last. Normally, I used to say this to you in the very first day. It doesn't work well. Okay. So the thing is, I couldn't care less about grades. The idea is that you come here to present something and really try to learn this, and present as you were, you know, looking for a job, or try to say, you know, this is what I would like to do in the future, and I would like to prepare myself to work in a technology or biotechnology company that will require me to explain this to someone. So the idea is that you come ready to discuss. And this is the stuff that, you know, in the beginning you go a little, oh my God, oh my God. No, it is, the idea is that the presentation side tends to look a little bit more like my laboratory meetings. So Janet presents something, and I go after Janet. Very nicely, we have coffee, it's awesome. But I go after it. Why? Because that's the way I think you learn better. That's the way I think you can be challenged, and this can be a nice opportunity. So don't be scared. It's awesome. It's nice. Grades normally okay, pretty good, but come with that mindset. Okay. So now what we can do is I can do 2 things. If you guys have questions about anything, either in this class or the previous classes, you can either ask me now, write me an email, we can set up meetings, we can set up in person, whatever. And the second one is I can stay here also for the rest of the class, and also by request to answer specific things about the presentation. Is that okay? Very good then. And if you have something else to do, that's fine too.
I have a specific question on the write-up part.
Yes.
So is it unclear, do we all write our own write-up, or do we, as a group?
As a group. As a group. Because this is supposed, like the one thing, and this is a good point. What I would like to ask you to do is, when you have the write-up, send it to me so I can send to everybody. Or you specifically, you know, this is something that I didn't do last year, but it's a good point. Again, is material. material. Like I did a one page exactly to be summarized, but it's also, oh, that's nice. Oh, you wrote here in the second line that, something happened in the cell. So what happened in the cell? So that's the kind of stuff. That's the main reason for the write-up. Okay. So again, it's how you write that, how you make that thing, it goes along with how you want to present, your slides. Questions? Concerns? No? Okay. So there is I think somebody have asked, I still have a few quizzes from previous generations there. And they, you can get there. We can have a 10-minute break. The ones that want to vanish, that's okay. The ones that would like to stay and ask questions, I'll give you. Okay? Thank you.
Yeah, in mine, like, they aren't actually the app that I want, but there is the information there.